Alright, so question 29 is a question from game theory on how options are not always necessarily a good thing. I mean, this is a thing that has been played out in history as well, but we'll get to that later. The idea here is simple. Consider these two separate games. Player 1 is picking a row and player 2 is picking a column. Now, in this first game, player 2 doesn't really have a choice, he has only one action. Player 2 picks between these two rows, and since -1 is worse than 0, he picks this. So, the outcome is 0-6. Now, in the second game, when player 2 has gained an additional action, here both people get to pick something. Now, let's solve this game. If player 2 picks H, then player 1 would pick this, right? He would prefer 0 over 1, -1. If he picks down D, then he would pick 3. Now, if player 1 picks E, then player 2 would pick D, and if player 1 picks N, player 2 would pick again D. So, note here that for player 2, D is a dominant action. D is any day better than H. So you're getting a new action, a new option which dominates the option that you already had. However, here the consensus choice that will eventually get implemented is 3-3, which for player 2 is strictly worse than the 6 that he was getting without that option. So what does this mean? This simply means that if you get a new option, even an option which is dominating the options that you already had, even then, it in a strategic situation where your opponent is rational, it might influence them into changing their choice because they see something better, and therefore might result in an equilibrium that is worse off for you. So in other words, if your opponent is rational, more options are not necessarily a good thing. Alright, so question number 30 is another question on general equilibrium analysis. As I mentioned in some question earlier, in any general equilibrium analysis, you can always, it's only the relative prices that matter, so you can always set one price to 1. So in this particular case, let's set Py to 1 and let Px be P. Now, agent 1 lexicographically prefers X to Y. What this means is that he would be willing to trade any amount of Y to get even the tiniest bit more of X. Also, agent 2 has a utility function of the form U2 is equal to min of X comma Y, which is to say that he wants X and Y to be in equal proportion. So now the initial endowments are that agent 1 has 10 units of good 2 and agent 2 has 10 units of good 1. Since the prices are P and 1, the budget that we are working within is 10 for agent 1 and 10P for agent 2. Now, since agent 1 only wants good X at any price, since that's the case, well, he'll spend all his endowment, all his budget of 10 on that one good which has a price P, so his demand would be 10 upon P. Now, 2 wants equal amounts of X and Y, X costs P whereas Y costs 1, so an equal amount of X and Y would cost P plus 1 per unit each of X and Y. Now, so then what that means is that the demand would be 10P upon P plus 1. So, now coming back to another fundamental idea in general equilibrium analysis, whenever you have multiple markets and multiple goods, here you have two goods X and Y. Whenever you have markets and multiple goods in general equilibrium analysis, whenever you reach an equilibrium, goods in all markets will clear, which is to say that demand will equal supply and they will clear simultaneously. So to identify a general equilibrium, we need to find the point where any one good has demand equal to supply. Let's look at the excess demand, which is the demand that is in excess of supply for the case of good 1, to see where the equilibrium would lie. The demand would be 10 by P from 1 and 10p upon p plus from 1 from 2, whereas the supply is 10 from 1. So 10 upon p plus 10p upon p plus 1 minus 10 should be equal to 0 in equilibrium. Unfortunately, in this particular scenario, this particular equation does not have a solution, which means that this particular problem does not reach equilibrium, and there is no equilibrium value of prices that can be attained, and therefore the answer in this case is that the competitive equilibrium price ratio does not exist.